In this section, we're going to discuss the basics of two-dimensional arrays. We declare a two-dimensional array by specifying a base type, which is the type of each element stored in this array. We give it two indexing operators, both of which are empty because we're only determining the type here. We're not trying to actually do any indexing, and we give it a name. The definition is when we say new and then the size of the array. That obtains memory and builds the array. It is an uninitialized data, but the proper amount of memory space is allocated. A declaration does not obtain memory. Definition does. This could be done in one line where we say the base type, index, name, assign, new, base type, row size, column size. So we don't have to do it in two steps. Once a two-dimensional array is declared, the programmer is responsible to initialize it. Usually this is done in a set of nested loops. For example here, let's say we're doing a 10 by 10 multiplication table. In one line, we would declare and define the array, int mult, index, assign new int 10, 10. That says we have 10 rows with 10 elements in each row. Then our outer loop, there's a typo here. The outer loop has II. It should be simply I. So let's just ignore that and move on. Outer loop ranges from 0 to 9. Inner loop, same thing. J assigns 0 up to 9. And in the array mult at row I, column J, we put I plus 1 times J plus 1. So we would build our multiplication table. We fill it row by row. The inner loop does the columns from index 0 to index 9. Then we go out and we start with the next row and continue. Initializer lists can be used with two-dimensional arrays. Similarly to a single-dimension array, we have values in a set of braces. In this case, the outer set of braces is the initializer for the entire array, inside of which are multiple initializer lists. In this case, we have row at index 0 with elements 1, 2, 3, row at index 1 having elements 4, 5, 6, index 2 would have elements 7, 8, 9. Notice that the rows each are bracketed by braces. Also, the count of rows and columns is determined by the data in the initializer list. To access an element in a two-dimensional array, the array variable must be followed by two indexing operators. The leftmost being the row, the rightmost being the column in that particular row. As always, the values of the indexes must be legitimate. That is 0 to max index, where max index is the number of rows minus 1 or the number of columns minus 1. Otherwise, we get an array index out of bounds exception. For example, to access the 6th row, 7th cell with indexes 5 and 6 respectively, we would say mult sub 5 sub 6 and assign that individual element the value 42. This approach works, but it becomes tedious. In so much as is possible, use loops to index over the two-dimensional array and do the access. If an array is specified by using an initializer list, then the programmer has not come up with a value to define the number of rows or columns. Therefore, to find out, we have to ask the array. In fact, this is the best technique you can use even if the programmer did specify the number of rows and columns. Ask the array how many rows it has. That's done by saying array name dot length. That says how many rows do you have. Each row has a number of columns. We would ask the row itself, how many columns do you have? Example here is matrix sub 0. Row 0, how many columns do you have? Most arrays are rectangular. That is, they have the same size rows. Each one has the same number of columns. In this case, saying mat sub 0 will work for any row. Some arrays are ragged. That is, each row may have a different number of columns. In that case, you must always ask the individual row how many columns it has. We don't want those array index out of bounds exceptions to be occurring. The data type of an array is somewhat confusing until you work with it a time or two. The examples we've used, mat and mult, were both defined as two-dimensional arrays that held integer elements. The array itself is not of type integer. The element type is type integer. The array is type array of int. Technically, each row is an array and its type is array of int. The 2D array is type array of int. The only operation that we find useful on types array of some type, or array of some type, that is the 2D array or a row in the 2D array, is indexing. Since an element such as mat sub 0 is type int, that element can do anything a normal int can do, all the math operations, etc.